All right, so today we're going to be solving and graphing compound inequalities. They're either going to be connected by the word and or the word or. And graphs are typically shaded in between the two numbers. So for example, if we have x is greater than 2 and x is less than or equal to -8, you would graph it so that you're looking at where is the overlapping section between numbers that are greater than 2, so we'll shade it to the right of 2. But then they also have to be less than or equal to 8, so we would shade in between +2 and 8. Notice this one's a closed circle and that one's an open circle. The union or the or situation is we want to know it can be in either this section or this section. So if we find 0, here's -3, here's -5. Right? I can have any number that's greater than -3, which is this section, or any number that is less than -5, which is this section. So we have two sections. All right, so we wrote down here, typically the and is shaded in between the two numbers, but the or is shaded outside of the two numbers. So find your two numbers and go on the outside. And the only difference here is that you can write it so that it's an inequality with three sides. So another way to say this exact same graph is we could say that x is in between 8 and 2. So sometimes you might see it listed like this, sometimes you might see it listed like this, and it means exactly the same thing. All right, if that's the case where you're originally given the three-sided inequality, then you're going to solve for x so that x is by itself in the middle section. All right, if you need to write these down, pause the video, otherwise we're just going to go on to the problems. So number 1 says solve and graph the given inequality. So you're going to look at these as like two separate problems. First solve this side, then solve this side. All right, so to get x by itself, we're going to divide by -2. So we divided by a negative, therefore we need to flip the symbol. So it's x is less than or equal to 6. And then here we're going to divide by 3. 3 is positive, so we don't need to flip the symbol. All right, and then it's connected by the word and. So one way to list your answer is like this. Another way is to say that 2 is less than x, which is less than or equal to 6. So we're just going to write down both for now. You might see something on a multiple choice test where it's listed like this or like this. And then we need to graph. So the graphing part, just find where your two numbers are. Make sure you do the correct type of circle, open circle or closed circle. And if it's and, you're going to shade in between. All right, this one, we're also going to just solve normally. So we've got 3x plus 3, because remember, first step is to distribute. It's less than 9. So now we subtract 3, we get 3x is less than 6. Divide by 3, we get x is less than 2. Over here, we're going to distribute also. So 3x plus 3 is greater than -6. Here, we're going to subtract 3. 3x is greater than or equal to -9. And then we're going to divide by 3, and we get x is greater than or equal to -3. So your answer could be listed, x is less than 2 and x is greater than or equal to -3. Or the other way you could see it is x is in between -3 and 2. Notice that I've got the or equal to here, but not here. All right, so find your number. We've got 2. Our other number is -3. We need a closed circle here, and we need an open circle here, and because it's and, we're shading in the middle. All right, this one now is or, so we're going to solve for x first. Subtract 4, we get 3x is less than -15. Divide by 3, we get x is less than -5. Notice that I did not flip my symbol because I divided by a positive number on both sides. All right, here I'm going to distribute first. 2x minus 2 is greater than or equal to 8. If I add 2, I get 2x is greater than 10, greater than or equal to 10. And then divide by 2, we get x is greater than or equal to 5. So this is connected by an or. There, you don't write it like this. This is only for the and graph. So these, we're just going to leave it as is. All right, so now I'm going to find -5 and +5. -5 has an open circle, but +5 has a closed circle. I want numbers greater than or equal to. Here I want numbers that are less than or equal to. All right, so technically when you do an or graph, it is possible to have something where the arrows go in different directions, but not in this class. And most of them, I think 99% of them are going to end up looking like this for ors. For ands, they're going to look like this. All right, so we're going to keep going. So we're just going to solve for x. We got negative x is greater than 2. Divide by negative 1. We have x is less than negative 2. Notice that we flipped our symbol. Here we're going to add 1. We got x is greater than 4. So we have x is less than negative 2 or x is greater than 4. So find 4 on your number line. Find negative 2. They're both open circles, and we're shading to the outside. All right, when you're ready, flip over to the other side, and then we'll continue the last few problems together. All right, so number 5, this time we've got, this is an and, we've got our three-sided inequality. Number 5, number 6, and number 8, these are all of our three-sided inequalities. So for these, this is where you want to solve for x in the middle. That's what we talked about over here. Solve for x so that it's by itself in the middle. All right, so I see distributive property. I'm going to distribute. I have 2x plus 6. Now I'm not going to change the 2 or the sign and bring down the negative 2. So these parts just came down. I just distributed my 2. Now I want to get x by itself in the middle, so I'm going to undo my plus 6. Whatever you do to the middle, do to the left side and the right side too. You just have to keep your inequality balanced. So this is negative 4 is greater than 2x, which is greater than negative 8. Then I'm going to divide by 2 everywhere. So I have negative 2 is greater than x, which is greater than negative 4. So this answer is good. You might want to flip everything over because negative 4 is the smallest number, smaller number. But either answer is really okay. Just make sure you realize negative 2 is here, negative 4 is here, and you're shading in between. All right, number 6, we're going to do the same thing. Try to get x by itself in the middle. So our goal is to undo the minus 4. Make sure you do it to all 3 parts. So you have negative 6 is less than 3x, which is less than 9. X is still not by itself in the middle. So we'll divide by 3. So just make sure you're trying to get the middle section to just say x. So we have negative 2 is less than x, which is less than 3. 3 I need to find on the right side here. Negative 2 is a negative number, so it's on the left side of 0. They're both open circles, and I shade in the middle. All right, so let's do number 8. That way it's the same as the other ones. So we're going to subtract 3 from all the parts. We've got 2 is less than 2x, which is less than 4. And if we divide by 2 everywhere, we get 1 is less than x, which is less than 2. So x is by itself in the middle. And I need to find 1 and 2. So notice that you have a kind of a small section there, but you still want to shade in between the 2 numbers. So just this little section right there. All right, number 7, we're going to go back to that one. So number 7 is an or. First I distribute. Negative 2x minus 8 is greater than or equal to negative 2. I'm going to add 8 to both sides. Negative 2 is greater than, negative 2x is greater than or equal to 6. When I divide by negative 2, I have to flip it, so x is less than or equal to negative 3. Over here, I don't have distributive property, but I have like terms on the same side of the equation, so I've got really 4x plus 6 is greater than 18. Then you want to undo your 6. So we have 4x is greater than 12, and divide by 4, so x is greater than 3. And this is an or. Always go back and double check what's the connecting word. So now find negative 3. I need a closed circle. Positive 3, I need an open circle, and it's or, so I'm going to shade on the outside. You can always double check. It's less than negative 3, but greater than, and, or greater than 3. All right, last 2 problems. So or tells me I want to shade on the outside when I'm done. All right, so if I move my x's over, I've got 2x is less than negative 10. Divide by 2, you get x is less than negative 5. Here, the only thing I have to do is divide by negative 3, but I need to flip my symbol, so x is greater than 4, and this is connected by an or. All right, so find your positive 4, negative 5. I want numbers less than negative 5 or greater than 4. All right, so your graph should look like that. All right, and then last problem, this is an and. So I'm going to move my 3x over here. So I've really got 3x plus 8 is greater than 5. Now I'm going to subtract 8. So I have 3x is greater than negative 3. And then when I divide, I got negative 1. Then on the other inequality, I'm going to subtract 5. Negative 3x is greater than negative 18. And if I divide by negative 3, I have to flip my sign, so x is less than positive 6. This is an and. So now anything with an and, you could also rewrite as your three-sided inequality. So the smaller number is negative 1, my bigger number is 6, and x is in between. So just make sure you recognize that these are the same thing. So find positive 6, find negative 1. They're both open circles, and I'm shading in between the two numbers. All right, so our secret word of the day is snowstorm. Okay, so if you were paying attention, you can write that down, and then you'll get full credit for your homework.